continuous rotation servos. And if they are, then yes, they can be controlled.
Tim, is that the sound that the feedback 360 motors make?
On this robot? Yep.
Sometimes. We were actually just were concerned over whether or not the motors were a little too loud for people who are used to our other ones. So I'm glad to hear they like the souped up sound. We do a lot of listening. Oh, they think they are quieter. Good. Yeah, Andy went to great lengths to talk about that with quality control and the design and manufacturing of those. And the sound output is actually part of the quality control test. So if you sound like little airplane engines, just let us know.
Andy, you could set up a example with that and screen share at some point here near the second half.
Okay. So you need an example of adding the 360 servos to the...
Yeah, if you want, might be good.
All righty.
While people are still joining in, should we take some questions from folks who had trouble getting their servo centered?
Yeah, we could do that. I have a place for it.
Yeah, this is Gene Clifford. I crashed and burned on Monday. My computer did not recognize the microbit as a flash drive.
Yep.
So I've caught up. You were kind enough to respond to several of my emails. The one thing that I've missed in the tutorials, though, is there are places, and it'll be there today in our navigation. It's going to tell us to enter and save certain files. They all end in PY, but they don't appear to be part of the cyber.py.
Yeah, so I'll cover that. I added your question to the agenda.
You are awesome, man.
Yeah, got you covered. I thought it was a good question. Anyone else have trouble with servo centering?
Amy White was having difficulties. She plugged her servos in properly and they worked when centering, but during the centering, the red light went on and it never worked again. She's unplugged it and replugged it. So
that sounds like a power supply. Which red light? If it was the flashing red light?
Yeah, this flashing light.
That's your low battery indicator. And did we swap out your batteries last time?
No, but my batteries are brand new. One motor works great, but the other one doesn't. The one in 19.
You can grab new ones.
What?
Do you have any additional supplies from us there? And were you able, did you try switching the two leads on the motors to verify?
You know, let me try that. I didn't.
Okay.
Try doing new batteries.
Yeah, sometimes like if you plug in one battery backwards, you're going to generate a lot of heat and draw them low, and then you will have bad batteries, especially leave them in there overnight. I've done this. I'm the heat generator at Parallax. Andy follows me around with a fire extinguisher and doesn't let me get on airplanes.
And I also follow you around and unplug batteries.
You sure do.
Because as you mentioned, yes, just leaving the batteries plugged in overnight can also drain them down because the microphone doesn't stop running.
I don't color in the lines. All those robots over there are plugged in right now. You could be the new safety manager at Parallax.
Either that or the batteries are.
Okay, let's get started because we have, whoa, everyone's here, 56. Oh my gosh, we've got a lot to talk about too. And so first off, just a little bit of housekeeping, public service announcements. The slides that we're using, this is where you can get them. These slides are supplemental material to the class. We use them for our educator workshops. So if you went into learn.parallax.com and you clicked on educators, then you scroll down to Cyberbot resources, and then you keep going down, you will encounter Cyberbot slide support material, and that's an open Google set of slides. And I'll be using them today. They supplement the tutorials and have additional information in them. So that would be this presentation that you are seeing today. And it's kind of handy to have it because you can copy code out of it. Okay. Second public service announcement is last time I did not properly introduce to you Stephanie. And Stephanie's here. I had a picture of her somewhere. Maybe not in this one. Stephanie, say hi again.
Hi again.
And Andy's here too. So they are co-pilots. So yesterday we were building the plane while we're flying it. Stephanie was asking questions. Next, the awards category. We may have some contenders already. Are you able to see the three categories?
Mm-hmm.
Let me just make sure.
I can see them.
Okay, great. Yeah, so no one's brought forth any animals or coworkers yet. This is open for claiming. We did have a big fail discussion at the end of yesterday's or Monday's Zoom meeting where it wasn't directly related to robots, but one of you was repeatedly shorting out batteries on a zero-turn radius lawnmower to the tune of $100+ per battery, blowing things up before they figured out something was wired wrong. So that prize might be claimed. Stephanie has grabbed a note about who might earn it. We had another self-proclaimed one that showed up by email, but the person did not want to divulge their identity. I'm showing that video right now. And this is, my servos won't stop. What's wrong? Someone tell me what's wrong here.
Because I guarantee you at least one of your students will do it if you have a full class.
We see this quite often. And the point here is another set of eyes is all it takes a lot of times. Come on, somebody come forth with an answer here.
Where they're plugged in?
Are they at 1617, not 1819?
Yes.
Almost.
No.
Oh, that might be might be one problem I didn't notice.
Is it that the microbit is on upside down?
Bingo. Okay, that's it. Yeah.
Oh, good.
So the microbit is not making any contacts with the board.
So it's both mounted on top instead of underneath, and it's facing the wrong direction. So
yeah.
We can see the parts as opposed to the LED display. And so we want to see it underneath and with the LED display. This is a very common issue. We get teachers calling in fairly frequently saying, hey, 8 out of 10 of my students got it running, but these two right here, just they won't work. And usually it's an upside down board like that.
Okay, and then the next thing was somebody asked about this gripper. And this gripper is something, it's a product we're coming out with soon. It's an amazing design. It's a single servo grab and lift that doesn't really have much regard for the diameter of the object, provided it fits within the jaws of the gripper. So this thing is totally fun. We're manufacturing them right now in Rockland on our CNC machines. They're gonna be a little expensive, around $100. And so teacher said, what about if we wanna make our own? And my thoughts to that are go for it. It doesn't have to work as elegantly as ours. Get a hot glue gun, get some of this kind of foam core board and give them one of these. And then get 2 servo motors from Parallax and then start cutting, because your board has additional ports on it for more servos. We are using 2 of them and there are 2 more. So start thinking about what you can build that is not just something that we show. Next public service announcement was about Mu. And Mu is an alternative editor to the online Python editor. And in the beginning, we didn't recommend it too much because it had trouble keeping the Cyberbot module on it. But you can get this editor at codewithmu.org. And this is a locally installed editor. And to add the Cyberbot module to it, you would just click on Files, and then you would go to your computer's Mu code folder. And if you put the Cyberbot module in there, you can drag it onto the device that's connected. So it'll just show up in this window. So it's pretty simple to use.
You're using battery. Oh.
Next thing was I'll close that file window. The microbit has on it a number of sensors. We didn't get to use them all because we're moving so fast through this, but you can explore them on the Make It Code It site that we looked at last week. And this particular sensor is the accelerometer. So I'll just flash the code for this. And I'm using print. So if you use print in the microbit Python editor, it has a serial terminal that will open up and then show you all the values. So we could take this over there. But this also has a plotter which can intercept those values. So what you're seeing right now is the 3 different accelerometer axes. So as I go up and down with this, that's the Z, the orange line. And then left and right is your blue, X, and then Y would be the green. It's hard to affect one without affecting the others. So I just wanted you to see that. I think that's pretty neat. Some code with mu. Next thing, going back to our agenda. Oh, yeah, this is very important. Tomorrow, we are talking about some cybersecurity stuff as part of this presentation, and we are working on continuously a cybersecurity curriculum for the Cyberbot. And through this week, Stephanie has posted 3 tutorials that have been written by Andy and the team from the Cyber Innovation Center, who we spoke with yesterday morning. That was Kevin Knowlton. And these tutorials are now shown in the Cyberbot assortment. So the 2 prerequisites I would draw your attention to are this one, the computer microbit talk, and then the dictionary primer. And these have really good Python programming concepts, and then examples about how to interface with a serial terminal and what's called REPL. So I'm going to assign those for you to look at tonight. And then the tutorial, the first cybersecurity tutorial we've released is this one, Radio Basics. So in order to demonstrate anything remotely related to cybersecurity, we need to be able to use the radios. And to get there, the first thing we have to do is be able to get them to talk. So that's what this does. As I mentioned yesterday, what's really wonderful about this is that with most cybersecurity programs, you need to bring in a computer system and then deal with the IT department and connect it to the net, etc., which you just really can't do very effectively. So we're taking what I call kind of a low-level basic approach to this, but students will be able to see and code things like key shifts, channel IDs, and various forms of encryption. So what it means for your robot is that if we were all in the same room, we would start out these tutorials by me controlling all the robots in the class at once. And I could do that just by tilting my microbit and using the accelerometer on it, and then sending some signals to all the robots in the class. But through the tutorials, we will slowly lock them down. People work in pairs and then see how they could use their own channel and their own form of encryption to keep the others out. So this is all coming. Andy did a great job. Good job, Andy. And
Thank
Stephanie, yeah, you're welcome. You pressed hard. So there's a lot here. And as you look at it, you can just scroll down to the bottom and then click to the right. And you can go to the next set of tutorials for it. So we try to, this is really well documented. He physically covers, where is the radio? You know, I got to see it. And then what kind of channels can I use? How far does it communicate? All this is in the tutorials. So I encourage you to grab a look at that.
And feel free to email me directly when you find all my typos.
And
You
mine.
can just email editor@parallax.com.
Yep. Everyone got that? Or just reply to a message too. If you find any Parallax email, we'll get it over to Stephanie. Okay, so let's move into the assembly. Since today's Wednesday, see how it went. And actually, let's answer one more question from Ed. It was the following question. He said, actually it's from Eugene. I hope I'm not drawing too much attention to Eugene, but you came across one of our Blinky Light tutorials. It was this one. And as you read it, you came down in instructions and it said, enter, save, and flash pin 20 to your microbit. Okay, it's a great learning experience. So I'm going to grab a set of hardware, put it in front of me, switch my camera over. If the zoom control bar comes back, and they're recovered. Okay, and we're just going to do this really fast because it's a great opportunity to reinforce some of the gotchas that occur on the way. So I'm lazy. I'm just going to copy this code out of here, and I'm going to plop it into the editor, which I've done. And his question was, how do I enter, save, and flash it? Okay, so I entered it by copying it in this case, but I should have just typed it. And what do I have to do to make this code work? Most importantly, let's making sure that we have the microbit Cyberbot module on our microbit, which we do, but I'm actually plugged into the wrong microbit, so I better switch over to this one. And then I'll check again. So I'm going to check. I have the module, looks like. There it is, cyberbot.py. And then I'm going to connect, because I have upgraded the firmware on this microbit. It will show up here. So I click connect. Now the flash button is available, so I'm going to go ahead and flash it. And you should see that LED is now blinking. It's on for 2 seconds and then off for 1. Okay, so let's say 2 things. It's boring, I'm going to speed it up. And then also I want to introduce an error in my program. This is something we haven't gotten to yet, but we're going to write a lot of code today. So I'm going to capitalize this bot. Python is case sensitive, and also we didn't discuss tabs versus spaces. We use only tabs for indentation. So I changed one line of code. I'm going to download it. And if the lighting is right, you will see that an error is being displayed on the microbit. And it's saying syntax line, syntax error, and then it's going to give me a line number. It's hard as heck to read, so this is really frustrating. So what you could do if you don't want to discover your errors on this display, you could click on Open Serial, and then you can reset the module in here, and it will tell you the error. And it says name bot is not defined. So after I leave serial, okay. So that's a lowercase. Suppose I leave the colon off here. And then I go to flash the code. This time it gives me an error I can almost read. Line 6. Okay, well this is interesting. So it's on the previous line or the line with the error. It said the error was on line 6, but it's really here on line 5. Again, to see that error, you can go to Open Serial and then reset the module.
Sometimes you have to hit, Control C
Control
and then
C.
Control D.
Okay,
There you
so
go.
these are both buttons. So if it doesn't just reset, hit Control C, then Control D, and it says line 6. All right. Eugene?
Yeah, Ken, just the only thing I didn't catch there was the save. So I type it in, I connect it, I flash it. Did I miss something?
Nope, that's it.
Now, Ken, make sure to in the script name field, go ahead and give it a unique name.
Mm-hmm.
And then, Eugene, the save part is to click the load and save button, and then download Project Hex. Later on, you can drag and drop that Project Hex back into the browser, and it'll open everything back up for you, including the Cyberbot module that you added to the project. It's much better than saving just a plain old .py file.
Okay, one more time. I gave it a script name.
Okay, you typed in a script name in the right side, and
Okay.
then go for the load
Download.
save button. So Flash, we'll put it into the microbit,
Okay.
and then load and save will save your Python script and the settings around it, like the whole project. So if
Okay.
you click load save, you come down to the blue button where it says download project hex. Click on that, and it will download the project for you.
Using the script name that I gave it.
Correct.
All right, good.
And don't worry about the fact that it says .hex instead of .py. It's actually better if you have .hex files, if you're using the online editor.
Yeah, we just work exclusively in this with this. Okay, so the Python script is just a text file, but Andy pointed out to me recently that the project text is everything. It's the script plus the settings for the module.
Okay.
So we just want to, as a general practice, download the hex file. Okay.
Ken, I'm a little bit confused about that. You said checking the serial. How do you do that?
Oh, okay. So the serial port serves a couple purposes. One of them is so you can get data back to your screen, and then the other is so you could see syntax errors. So I'm going to introduce an error right now in this code. I'm just going to remove the colon after while true. And then I'm going to flash it. So there's no, I don't think there's a compile button. We're just going to compile and download. And my microbit starts to scroll an error, and it says syntax error, something or another. You won't be able to see it. It's really hard to read. So how else do I find where that error exists? Open serial by clicking on the open serial button, and then it'll display the line of code that has the error. Is that clear, John?
Thank you very much.
Sure.
And we have one more question for you from the chat, and that is, how do I open a hex file? To demonstrate that, you could close serial and then actually refresh this browser.
Oh, okay.
When you refresh the browser, you'll lose all your settings.
So I
That's
just
scary.
refreshed browser.
Yeah, and so now you've got the default, and if you hit load save, you'll see that there's not even a Cyberbot module inside your see it's show files 1, and all you have is your main file. So you don't have your code anymore, and you don't have the Cyberbot module in there. But if you open your file browser and then drag and drop the hex file you saved earlier from the file browser onto the web browser, you will have everything back that you were working with.
So Andy's asking me to power use it. All right, so I'll do that.
Or how to get your students unstuck when they hit that button.
So what I did is I took the browser out of maximize view, and I just kind of,
Can you close the load save button?
Oh yeah, just like that. All right, so
Okay.
here's the prior program that I saved. It's LED blink hex, and I could just drag it onto the microbit Python program, and then it replaces what was there.
And also, in addition to replacing what's there, if you go back to load save, you will see that your Cyberbot module is back.
Okay. And I have to be able to see the buttons to know where that was.
There it is.
So the Cyberbot module travels with the hex file.
Assuming you've added it. It's very important to essentially save your files using that download hex. And then anytime you need to reopen a file, just drag it from your file browser right into the web browser, and assuming that you're at this web address, and you'll be back working on what you were working on before. It's kind of like, it's the equivalent of opening and closing a normal document. This is the web version of it.
So as a rule, hex files store with them all of the modules that you've added.
Provided you're using the online editor. If you're using Mu, the rules are, it's a different set of rules, and it takes a little bit more reading in the tutorials.
Briefly, what I like about the microbit system with Python is that it has all the pieces in it that a real engineering tool have. They're just kind of lighter duty and easier to use. So if Andy were writing some code that goes into a chip that we put into a product, he'd be using tools with similar capabilities, but far more features. And this thing is sized just right to get your arms around it and grab it and use it. Students can do this. But these are great questions, and they are kind of all the hurdles. I don't know the right term to call them, or the gotchas. But once you get over these little bumps, then it's a matter of making code and circuits that match and understanding the hardware and limitations of the robot. Great questions. Anything else? And then we'll move into making this robot go. Okay, I should point out too that that little circuit we just built, or that was pre-built on the board with the LED flashing, of course you can build that on the breadboard too. You could just change this I/O pin number from 1 to anything that is on the Cyberbot board that you can use. That's 0 to 15 next to the breadboard.
Hey Ken, I'm really sorry. Where was it that we got that Python library code from? I just tried to connect everything back to my microbit.
And yours was missing.
And it's missing.
Okay.
So I guess I didn't do that download project text thing or whatever.
All right. So you have two choices. In your case, it's going to be in your downloads folder from yesterday. So if you navigate there, you'll probably find it. But for those that are looking for it for the first time, because some people did miss and we made them watch a 2-hour video to recover. If you go to tutorials on learn.parallax.com, click on Cyberbot, then it is here, add modules to your microbit. And if you click on that, you'll find the Cyberbot library archive, takes you to the Parallax site. It's a series of steps. And then you'll grab the latest one, download it, unzip it. So check, in your case, Joan, in your downloads folder. If not, we'll chat it to you and straighten it out.
Oh dear, because I have it, it's there. Now how do I get it from there to my
back
microbit?
to the microbit. Okay, good question. We'll do that again because you're not the only one. The other 42 are just being quiet about this. So click on Load Save.
Load Save, okay.
And then go to Browse for a file. First blue link, it will open your file navigator, whatever it's called now. And then navigate to where you've stored cyberbot.py. And you'll see it in the root directory that you've unzipped.
Okay. All right, and now it should be there. All right, so do I now do this like download project hex so that it stays there?
Yeah, I mean, so it's going to stay unless you replace this hex file with something else by dragging and dropping. But just save your code as you go. Okay. So as you work, hit load and save, and then download project hex.
You could even save it as blank Cyberbot project, and that way you can drag that one to your browser every time you want to get started, and you won't have to go through the process of dragging your Cyberbot library over next time you start your browser.
Thank you very much.
So the benefit of these web-based tools is there's no software installation. The drawbacks are kind of the file saving bit.
One thing I did was pasted in the reference to the Cyberbot library in the chat here. It's under the reference section of the Learn site. It's because David Culp had a question, is the Cyberbot module allowing a serial USB I2c access for attaching serial devices like the PixieCam? Now, I know Ken has played with the PixieCam on 2 of our other robots, and I don't know if that's beyond the scope of today, but I wanted to link that reference in there as a place to start.
Yeah, beyond the scope of the microbit capabilities.
Okay.
As far as I know, but you can use there are some native microbit pins that are not going through. Which probably brings us to this diagram.
Okay.
For the moment. Good timing. All right, what's on this board? I always like to learn through the process of discovery how things work, so I'm more of a hack. Not the best reader, so I'm kind of taking you through a similar process where we're using things and learning about them as we go. This is what's on the board. And we didn't talk about it very much, but you've played already with half of these pieces. The one that we've seen come up several times, number 7, this is a flashing red light. This is new on Parallax boards. It used to be difficult to figure out when power supply was a problem, but your robot would reset and then keep running the same code. In this case, you'll get a red light that goes on before the microbit and the accessory circuitry shuts down. So you've seen that flashing red light already. There is a port here for speaker. You can plug in your speaker and start making sounds. That's number 4 on this picture. Of course, your power jack, you know about where the microbit mounts. And then there are 2 built-in LEDs, and then there's a breadboard. So we're gonna get to the breadboard at the second half, or I would say third half now of today. So that's a quick look at it. Now, what else might you like to know, and then how much your students need to know initially? Those are 2 different things. What's happening when you write your code is it's downloading to this microbit module, and then behind the scenes, okay, we have a coprocessor. And if you look on the bottom of your board, I can show it, you will see a big square chip in the middle, okay? That chip is there to do things that we need for all of our robotics projects. So the microbit isn't perfectly capable to have the specific timing we need to control motors just right, to generate pulses for infrared, and to do things all at once. So we actually have this coprocessor on here. It's called a propeller chip. It's something we make, and it's transparent to the user. All right, so when they're writing code with this bot library, it's actually talking to this chip through what's called an I2c bus. It's a communication style that electrical engineers are very interested in. And then that chip actually makes the signals on this line of I/O pins that are numbered P0 through P15. Okay, so when you give a command here, bot 18, turn an LED on, or I'm sorry, bot 13, turn an LED on, that comes out on this pin. All right, so this is a helpful processor to make everything go, but not necessary to understand the intricacies of this for a student. Okay, briefly, how did the build go? Everybody, thumbs up. Was it fun? Okay. All right, yeah. Not fun. The lock nuts are a pain. I know. I can hear you. Trying to get the, and so students will cross-thread them. They are a pain. All right, once you've got your robot assembled, it looks something like this. And this is with the servos forward mounted. Because we went through the process we did last time, you probably put them together with them more towards the center of the robot. So we're going to be giving some commands to the robot. We're going to write some code, and we're going to make the robot go. And in doing this, I want to tell you what's happening behind the scenes. Once you issue this command for speed, and these values can be -100 to +100, there will be a signal that is given to the motor that is repeated over and over. So we'll call this set it and forget it. You're going to set the speed in code, and until you change it, that is the speed. From an electrical standpoint, what's happening is our chip is giving a little pulse of different widths to the motor every 20 to 40 milliseconds, or 20 milliseconds. And that maintains the motor speed. One other thing here is that, this is probably a better picture for it. Servos move in opposite directions to make the robot go forward. Don't want to get too wrapped up in this, but basically if you turn the robot upside down, you'll see that one servo had to be flipped on its side. It's actually turning counterclockwise, the left one is, to make the robot go forward, and the right one's turning clockwise. So what this means from a code perspective is the following. All right, to make the robot go forward, you'll give your left motor a positive speed, let's say it's 75, and you'll give an equivalent negative speed to the right one. And this kind of design choice that we made is really somewhat arbitrary. They could have been all positive numbers, but we decided to make it a little bit tricky to represent the physical orientation of that motor. So going forward, here's a little cheater chart that you can bring up. It's in that Google presentation that I shared. This will help you. There are lots of ways to turn your robot. You could turn a robot to the right by locking your right wheel and then having your left one go forward, right? But all of you that live where there's a lot of grass probably have 0 turn radius lawnmowers. And because in California, we don't get to have a lot of grass because we're drought half the year and we don't have big properties, we don't hardly know what a ZTR mower is. But your ZTR mowers do something that's not shown in any of these pictures. They turn in place by reversing one wheel. So that's how a Roomba turns. Robots turn on a dime, we should say, so they don't get stuck. Yeah, okay. Some new information, some not. So like if you're running into a corner here with your robot, it might be, you aren't going to escape that corner by continuing to go forward because you'll just keep hitting it. But you might be able to turn in place, reversing the wheels entirely. Like this picture. I didn't know I have a photo for that. So if you give them both the same value, it'll turn in place. So let's work with this. I would like us all to enter this code. And I'll tell you what I'm going to do is I'm going to do something Andy trained me to do the other day, which was you could take a tab off of your Chrome browser and then you can push it to the right. And it didn't work, Andy. I guess I have to have both of them present to do this. I want to get the Python editor next to my slide. So I'm going to try it again. It might be because I have multiple screens set up. It's not easy. Yeah, okay. So anyway, I'll just manually arrange it.
You have a request to show the code?
Yep, code's coming.
Sorry, it didn't work out, Ken.
Yeah, I think when you have dual displays, it's not as simple.
Yeah, I noticed that I have one display above the other, and when I smacked it up against the right side, it made the page longer so that it covered both the top and bottom displays, but it was nicely connected to the right.
Andy is one of the very few distinct breed of parallax people that can really configure a computer duty once during a presentation with multiple cameras. I always brag about you, Andy, with this. I'm sorry.
Thanks, I think.
Yep.
Ken, I'm sorry. How do we get to the from Cyberbot import at the top?
Okay. I'm not sure I understand the question, but ask it again.
On your Python editor, at the top there, it says from Cyberbot import. On my Python, it says from microbit import.
Okay, so you're just going to type right over it, and then you'll be, and then we'll make sure again you have the Cyberbot module on the microbit. So just type it, yeah. And this is a great time that we start typing code and we start introducing syntax errors and getting familiar with this, because you definitely will learn by doing. So just go ahead and copy what I've got, and you can avoid these comments. This is a progressive code that we're going to walk through. You can leave the comments out with the hashtag. So yeah, to get to the whole Python bit, we had to do everything we've done so far.
I have a question.
Yep, ready for questions.
Okay, so once we program it and the robot does that, should we save it like as a as code, or do we just load the next code and go on?
If you want to save the iterations, it's up to you. So I think this should be kind of a progressive code example,
okay,
but just save all the time.
Okay, thanks.
Yeah. And again, anything that you feel like, I wanted to have that, I really wish I didn't miss that, it is in the Google presentation that is linked in learn.parallax.com under Educator Resources for Cyberbot. So you can get back here and I'll send you all a link anyway.
I put it in earlier in the chat thread.
Awesome. Thank you.
So if when we flash this, nothing happens, we did something wrong?
Okay, that's great. Glad you asked, because likely the switch is in position 0, and to make the robot go, you'll need it in 2.
It is in 2.
Oh, okay. And
I had to press the reset button and then mine went.
Yeah, I wonder if you downloaded it in 0, then you moved it to 2 and it had already run. I'll flash mine and just describe the process so it could be duplicated. So I usually download it in position 2, or 1, I'm sorry, and then I move it to 2. Sorry for all the mess on the screen there. I'm just switching over to different microbit.
I still have nothing happening. Am I the only one?
Okay, I'll try to duplicate what you're seeing now.
I also had nothing happen, but I'm...
All right, I'm going to make sure. So in mine, it looked like it did not actually download. Okay, so it should go forward for 3 seconds. So after you download, you could switch it to position 2. And then to reset it, underneath the microbit, next to the USB cable, is a reset button. So the process I use is like this. I put the robot in position 1, I download the code, but I don't really want it to roll away with the USB cable connected. So I will then put it in position 2 and then press the reset button, which is underneath the microbit next to the USB, and then it will run.
When you do that, when you've disconnected the cable, flash disappears as an option, right?
Right.
And so when you plug the USB connection back in,
Then you have to reconnect and then reflash.
so you have to hit the connect button, and then the download button will turn into a flash button?
Exactly.
Okay. If you're in
so,
the online editor.
Exactly right. So I'll walk through this again. I'll wait a minute though till others catch up.
While others are catching up, I have a partially unrelated question. Is it possible to rename the ports 1819 into left, right, or something along those lines?
Sure. Provided you define them. And I'm not a
define them as
Python
a variable?
expert. Yeah, you could do that, right, Andy?
Yes, just basically at the top of your program, you could say left equals 18. Is that correct? Is left 18 and right 19?
Right.
Okay, so you could say left equals 18 and then right equals 19 just up on line 3. And then you could substitute left for 18 and right for 19. Warning about that is that with the microbit, the Python runtime itself takes up a lot of memory. So we try to use the least characters possible in programs because it actually does take up memory. This is a place where comments are not beneficial because every one of those characters also adds to the program size, and there's a small amount of room because the microbit is more about having the learning experience rather than developing large project level code examples.
Got it, thank you.
Mm-hmm.
You can also define your speed constants and then get rid of the negative sign and just put it here where the number currently appears, and then work with positive numbers if you want.
We have a number of different results that people are getting.
All right, let's share them. Maybe what I'll do first is walk through the process I use to flash the code, and then we'll see if any of those questions go away. So I have a complete script here, and I would like to download it to the Cyberbot and see it run. What I'm going to do, since I was just disconnected, is click on Connect, and then select the microbit, choose Connect, and then that download button turned into a flash button on the left. So my robot is now in position 1, which means the motors are not powered, but there is power to the breadboard area. In fact, you can do this with position 0 since the microbit is powered from USB, but just as general practice, put it in position 1. Click on Flash. Code is now in the microbit. Okay, the robot's not moving. So what I'm going to do is just connect USB cable, and you can do 2 things at this stage. Go from position 0 on the switch to position 2 and watch it run. Rolls away. Or you could just reset it, still in position 2, so the motors are powered, by pressing the button that's on the microbit bottom next to the USB port. There's a little button there. Not the 2 buttons on top, those are A and B, but the one next to the USB cable. So that resets things and runs your code from the top. Now let's see what kinds of questions we got in chat. You can ask them there or just enable your microphone.
We have some, Ellen says that hers doesn't move at all, even though the code looks just like Ken's.
Okay, and we
First
might...
question, when you reset, when you press and release that reset button, do you see any red LED messages scrolling across the microbits display?
We're hoping that she has a syntax error.
What was weird, Ken, is I had a syntax error at first, and I did see the flash, but it still ran. It just went in circles. So I thought that was interesting. That it would run slow.
Okay, so knock out a few questions here. In the order I'm seeing them, if one servo's not centered, yeah, it looks like this was answered. So if you give it a speed of 0 and it still is moving around, that's just because your servos aren't perfectly centered. Not a big deal. Generally, robots don't sit still, but you can go back and recenter that servo. So Ellen's, hers doesn't move at all. Code looks just like Ken's. So with Ellen, what I would probably do is look at her servos to see that they're properly connected into 18 and 19. I would go over, make sure there's no red flashing light. I would probably check the sequence that you downloaded and have you do that again, which would be flash and then put the robot in position 2 and then press reset, and then see if it goes.
If when you click flash, an orange light flashes underneath, but nothing moves.
Okay, that means the code is definitely flashing, but if there's no movement, something else is not right. You do not have to unplug the battery to avoid frequent dead batteries with this robot, provided you leave it in position 0, which is off.
Could you show the reset button location again?
Sure. So you'll see the USB port, and then on your right is a button, or actually your left. Got to figure that out. Okay, on your right is a little button. So you can just kind of put one finger on top of the board, your thumb, and then put one underneath and press that button, and then the code will run. As an alternative, if you don't like to reset that way, you could just be a slide switch user and then put it on 0, and then back to 2. Same result. So I'm curious if any who are not seeing moving robots are now seeing moving robots. Joan, how about you? Okay, Eugene? Success? And I'm just picking on those who are at the front of the class.
Yeah, this is Eugene. I'm good.
Okay, let's give me some thumbs up then or thumbs down. All right. That's good. I'm seeing all thumbs up. Don't be embarrassed if you got a thumb down. Neil, that looks good. Cool. Okay, you guys are really cruising. Let's move on then. All right, so what's your guess to make this robot go backward? Someone shout it out. We don't have to all do it.
Change the signs.
Yeah, exactly. Okay, so change the signs. All right, let's look at something a little more Python-ish. Progressing here. So I'm just going to paste in some code so we don't have to look at a bunch of things and have me configure Windows. Okay, actually this is worth looking at, so I'm going to bring it over.
So some are saying, Faith just said that when she toggles from 0 to 2 on her robot, it doesn't reset the code. And a number of people have it's not working.
Okay, toggling from 0 to 2, not resetting the code. That's unique.
Yeah,
Andy?
so basically, if I upload the code, then it works. But like once I've run the code once, if I go to 0 and then back to 2, it doesn't go again.
That almost sounds like an equivalent of a RAM upload in something else, like it's not, like its memory is lost.
Okay, so the way the Cyberbot works is if you have a program that just runs out of code, you need to turn the switch from 2 to 0 and then back to 2 to get everything restarted. Alternately, you can add, I think it's bot.detach at the end. Yeah, bot parenthesis, open close parentheses, dot detach, open close parentheses. And what that will do is enable the reset to work the way you expect it to. Most of the time and most of our programs after these single pass programs happen in a loop. And whenever things are happening repeatedly and you press and release that reset, you will have the kind of experience you expect when you press and release reset.
It makes a difference if you have the USB plugged into your robot because it's still receiving power. But if you unplug the USB and then flip the switch from 0 to 2 and back, or from 2 to 0 and back again, then it cuts off power to the Cyberbot and then it works.
Thank you. That's a really good point.
Yeah, it was plugged into the computer still.
Yeah, it's only when you, as he said, it's when you're plugged into the computer with USB, the microbit is still receiving power. And when you have a program that's happening in a loop, or if you add the bot.detach at the end of your single pass program that just kind of runs out of code, both of those will make the reset button work the way you expect, even when you're connected to USB.
So here's another example. Moving forward, this has a repeat loop in it. And I created a variable and then I repeated this 4 times. So a square is going straight, turning right 4 times. And you'll see the syntax or something new for y in range, parens, starting counter and then finishing counter. And that 4 is not the last count. It's actually 3 in Python. So you can start counting from 0, 1, 2, 3, and that's 4 loops. So it's exclusive of the last number, or n-1, or whatever math teachers would call it, or programmers. I know there are a lot of Python programmers on here. You guys can jump in and correct this. But I think you could try this program if you'd like. We'll stay here for a minute. Andy, since you're here and you're the nomenclature expert in parallax, I invite you to talk about, just very briefly, point to the object, method, and the functions in here.
Okay. Well, everything in Python is an object, it turns out. Your variables, the function calls, or functions, that they all are objects. But when you see bot of 18 dot servo speed of 75, that's a function call. So when you see something separated by a dot that has parentheses on the right, that is a method call. I might have just said function call. Sorry, didn't mean that. Now, a function call is down below where you see sleep. Notice it's not separated by a dot. And so what that means is that inside the microbit module, there is a function called sleep. And then inside the cyberbot module with this bot of 18 dot servo speed, that is a method. And it's probably going to take a while. It would take a while for us to write both functions and methods to see the difference, but they behave similarly. A method is essentially, I don't want to keep rambling about this because it becomes jargon until we've done it.
But once you start using it and then you look in the library and you see what the library supports, you'll understand what can go after bot 18 and 19. So like here it's servo speed, and that's a function in the cyberbot module. So when we call it a method. Call it a method, but when we show the list of what's in the module, then people will start to get it, I think.
Okay.
But even after chatting with you about terminology, I'm still messed up between my experience in basic Python, Pascal, sort of C, and lately Blockly.
Yeah, becoming multilingual has its gotchas.
Should have been a child.
Yeah, during Monday's webinar for the Arduino, somebody asked about single quotes versus double quotes, and all I could remember was the Python rules. And even though I'd written the particular book we were working out of about the Arduino, somebody else had to say, "Hey, look on page 18. There's some single quotes," and the book describes what they're about.
Anyone get this program running and see it? Maybe a thumbs up. Just kind of move on.
Hey, Ken, this is Rochelle. I wanted to check the red light for indicating power. Is it supposed to be flashing or just solid red?
Flashing.
Okay, good. It's flashing. I'm good then. Thank you.
But that's bad though, right? Because your batteries are low.
My brand new batteries are low. Okay.
It's possible. I mean,
I know that's Costco for you.
Huh? That doesn't seem right because we buy batteries there and have good luck in our classes.
Well, I can swap them out and put another batch in to make sure.
And so as you all go down this road, the next tool you want to acquire is one of these. All right. A multimeter. I think most of you have it, and you can just put it into DC mode and then measure your batteries on the power jack. And the way you would do it is simply pull the power jack out and then put the positive inside of the barrel jack connector, and then the shield of it would be the negative, and then you can get a reading on your battery voltage. And my multimeter is toast, so I will not finish that demo. Must have left it on. Okay, so seems like you're getting this. We're running this code. So moving forward, let's just look at a few more things here. So here is a function call. If you notice, this looks a lot easier. When this program runs, these definitions are stored and then skipped. The first line of code that runs is this straight function call. So it goes right up here to the top and it goes straight. So this is a simpler way to reuse sections of code and not be very verbose, which is going to matter, like Andy pointed out, with the microbit. So you have to be able to write very efficient code. And that's what I like about this. If you're sloppy, you're going to run out of space. But if you get creative and you have basically less characters on your screen in this case, and you learn to write more efficient code, you can do more. Occasionally we'll hear of teachers running out of code when they start really combining things, but we're hoping that Microbit Foundation solves this problem soon. Hint, hint. Okay. And then you can also pass parameters, all right, as arguments, and that's what we're doing in this example. And these examples are not in the tutorials. The tutorials we've kept kind of simple, so we've held this out to give the teacher some ability to have an edge here on the students, because we know you need it, right? I would. So they might start out by writing very verbose code, just copying and pasting like mad, and you can just say, wait a minute, let's put that in a function, and then just parameters. Here we're only passing the duration, but we could also just write this with one function and then call it drive, and then pass the left speed, right speed, and the duration. So I think the Python programmers out there are probably starting to salivate over these details. Yeah, this will get you where you want to go. Oh, here's actually a partial example of that. So I am passing 3 values here, the left speed, right speed, and then the duration of them. And there is another little trick shown in this code, which is we're working all with sensible positive numbers. You'll see that when we pass them as parameters, we replace them with these constants, VL, VR, and milliseconds, and then we switch the sign on the VR one to make sure that it is opposite, but we're working all with positive numbers because it just seems easier for some that a speed of 100 and 100 is forward on both wheels. And minus 75 and minus 75, or minus 100, minus 100 would be backwards. Give me a thumbs up on all that if we got some agreement to that. Sensible? Okay. Good. All right. Yep. And then moving on. So something like this, following a path. I don't advocate just trying to do exactly like this because you'll never really stay on it. But let's say you had like, you know, a maze and you could outline. One thing we like to do is just outline paths and then have the student try to stay within that. So 10 inches apart, 2 lines of blue tape. And you can test them by seeing that they can go straight, right, left, and generally understand the navigational routines. And to do that, you'd probably use code like this. And then just a really quick show and tell. This is a line follower. If we get more entrants for our biggest fail, biggest winner, best coworker, someone might be winning a line follower kit. No one's brought forth any animals yet.
Oh, we have submissions.
Is there an iguana?
There is no iguana, but you have one email to you.
Okay.
You have one email to you from Joan, and Elizabeth also sent me a marvelous picture.
All right.
So we're going to have some contenders, I think.
We got some players. So some of the prizes you could win would be this sensor. This is a ping ultrasonic sensor mounted on a servo. We might even give you choices. That's a must-have. And then, of course, there was a line follower. That's really cool.
Custom
Things
snow
like
tires
infrared.
not included.
You can make your own. Again, like I said earlier, hot glue gun, 440 screws, a trip to Ace Hardware, and you're good to go. Okay, so let's move on. And then briefly, since we're running out of time, we'll go to 9:15 California Pacific time. We will take a quick look at this slide. What is in the bot library? This is when your world just gets much larger. So this is all stuff that the Microbit Can't do too well on its own, but is made very possible through our module, our CyberBot module, and the processor on the bottom of the board, the Propeller Chip. So some of the things in here you'll see PWM, its analog output, reading states of pins is high or low. We have a method for reading QTI sensors, those are the line followers, generating sounds, and then part of your homework, you will use some of these others. Infrared detect, TV remote allows you a one-line command to read something like this. So for those of you who've used, say, like maybe the basic stamp, like Faith, or the Arduino, she'll really appreciate these things being packaged up this way. Your piezo speaker can plug in there, and then you can add the tone function into your programs and generate sounds to play things like, let's see, I might have an example on another robot. Well, those examples probably don't apply. Well, I do have the Cantina band. Maybe that will work. And then we're going to look really quickly at the Whiskers and get out our parts and just talk about what you'll face tonight or this afternoon. All right, so let's move on and talk about Whiskers, unless there are other things of interest at this stage.
Ken, just a quick one. You showed the ping. We purchased the ping for the Bobots. Will it work with the
Sure. Yep.
Thank you.
You bet. Just plug it right on top of the breadboard right here, just like you have in the past, and you're wire it up and then write code for it.
Excellent.
Yeah. So circuits. Okay. As we jump into circuits, breadboards may be new to some of you. Parallax specializes in circuit building, coding, mechanical interaction. So we don't really favor a lot of pluggable modules that have everything pre-built. We like our students to build so they could really see how things work. And this is a part of the process of failure and learning and frustration and huge reward. I think it's tremendously worthwhile. So our standard on all of our products is a small breadboard and has been for 20 years. We try not to change things for teachers too much because we do not want to obsolete their hardware. I've been in 1,000 classrooms and I get ill when I see piles of invested hardware from various places that are not used. So we try to keep things consistent. Briefly, breadboard, and this is described throughout our tutorials. You can research it and find videos on our YouTube channel, but basically the left side is not connected to the right unless you connect it, like shown with this blue jumper on the bottom. And the rows are connected, the columns are not. So I should have a breadboard here to take apart. Maybe I'll show you one tomorrow, but when you take them apart, you'll see a metal strip underneath it. So on the right picture here, you could see the yellow wires not connected to the blue wire because they're in different rows. But on the left one, they're in the same row, so they're connected. And then also for the bottom, look at the breadboard. You have to do what we call jumper from left to right side to connect the yellow wire ultimately to the blue wire on the right. So a little more detail. Again, this is from the Google presentation that I'll send to you and Stephanie put in chat. Resistors. So you'll now be getting into resistors. If you are over 40, this will be a problem. They come in bags like this. And there's a resistor color code so you could find the right colors. Good luck with that. We try to keep it simple. This is a first circuit you may or may not want to build, but I'm going to take you straight down to the Whiskers. I'm going to do that through the tutorial, so I'm going to jump over there now. And we're going to get a look at it. And I would like to use this as a chance to show how we present these things. So I came into the CyberBot tutorials and I am jumping into on class hour 20 here, touch navigation for the Cyberbot. When you open a parallax tutorial, you will see first a video, usually that looks like this, that kind of shows what's going to happen. So this is your very first sensor feedback system, and it's just a little bump sensor. So we give a video to entice them, and then we show, scrolling down or clicking through the right, how it's built. So there's usually a list out the following parts. If there's some physical considerations towards building it, you'll see a picture like this. And we provide steps. And then, very important, you will see both schematic and a pictorial representation of what we're asking you to build. And I learned this way too, actually. I didn't know a whole lot about electronics when I started at Parallax, but the first thing I did was hire Andy, and he's an EE. And then he started writing books, and I started learning from what he was doing while I was trying to tell him what to do, even though I didn't know what he was doing, because I was like a user. And so you can start with these pictures, but you'll move to these schematics very quickly. And in short order, you'll understand how to read a schematic. So we show both, and students will take this very literally. They will look at this pictorial and plug everything into the exact spot. But trust me, over time, you'll see them change, and they will go towards schematics. And then they'll start to figure out how to put multiple things on one breadboard, because any challenge you do of combining circuit A with circuit B, well, we don't give you pictures for that. You'll have to figure it out. So we'll go over how this works briefly. So when you have these whiskers on your robot, let's go back to that picture. Maybe it's in testing. Okay, this is visual feedback. All right, so the whisker. When the whisker is not pressed, which is on the left side, then the ground is actually the I/O pin. Right, Andy? Do I got that correct? And so you will see 0 when you read the I/O pin. And then when it is pressed, which would be this little switch going here.
So Ken, there's a picture a couple pages forward. It's how the whisker work, yeah, there you go, how this whisker switches work. And
okay, perfect.
Here we are. So now on the left, basically the P7 in the little in the propeller square on the left, it's connected to a circuit, but because the whisker, which is connected to ground, is not pressed up against the post sticking out of the breadboard, all that P7 can see is 3.3 volts through the circuit. And so when you say bot 7.read digital, you get a 1 back from that. Your script does. Now, if instead on the right, the whisker is pressed up against the post that's sticking up out of the breadboard, the P7 pin actually sees ground because it's looking through almost no resistance to see ground. Another way to think about it is when you say read digital, what you're asking is, hey, is the circuit connected to that pin? Is it closer to 5 volts? Or I'm sorry, is it closer to 3 volts or is it closer to 0 volts? And on the left, the way that circuit is with the whisker not pressed is closer to 3 volts. On the right, when the whisker is pressed, it's closer to 0 volts. And so because of that, it gives you back a 0. And that's the whole idea of binary 1 and binary 0 with literal mechanical switches.
So in terms of testing this, we have incremental steps of code. And the first one, we'll just test them. And this is subsystem isolation. So we don't build a big monster circuit and then code it and test it. We build things in pieces. So here on the second page, testing the whiskers, you'll see that the code is designed so that when you press the one whisker, an LED goes on that whisker side on the microbit. So this is giving you visual feedback. And if you press both of them, then we've configured it to turn on 2 LEDs. So this first code segment will just test, and there's no rolling around of the robot yet. And then once they work right, then you can move on to description of how the test code works, and then actual navigation with Whiskers. Navigating by touch. And here we use if and else if and else. And some functions. So your assignment tonight, we'd hope to build these here today. As you go off and start building things, some tips I'll provide you, and I don't have the right camera for this, but you'll want to make sure that the whiskers or the resistors are not touching each other, all right? They can be very close as long as they're not touching. Pay careful attention to the physical arrangement of things so that when you have just a light press on the whisker, it hits the post. Right? These are what we call 3-pin headers, and they're just little posts that you can drop into the breadboard and allow the whisker to make contact with that hole in the breadboard, which again is connected to the I/O pin and to 5 volts. So there's a physical requirement here in setting things up that you have to consider.
Can we ask for a thumbs up and thumbs down view of who's used a breadboard before?
Breadboard thumbs up.
And okay, so it's most but not everybody.
Okay.
Okay, I just wanted to point out that it'd be tempting to jump right into the Whiskers tutorial, but the one to do before that, if you have not used a breadboard, is circuits on the Cyberbot that explains, that I linked down there, that explains how a breadboard works and what the connections are.
Is this the correct part?
Yes.
Thank you.
And Stephanie, just to point that out, circuits on the Cyberbot, if you want to go backwards and do some earlier work, she put it in chat, but it's also right here. So we've got a number of detailed examples you can walk through. Are there any questions at this point? We're at 9:15 Pacific.
I have a question.
All right.
I lost one of the screws, so now I see that I need the other post for the next assignment.
You're just missing parts then?
I'm not, I might have lost the longer screw here, so I do have the post, I just can't screw it in.
Okay, and so you have the screw, but not the standoff, I think.
No, the other way around, hold on.
Okay. All right, so we'll get with you and we can drop some pieces in the mail to you.
And I have a quick thing about that. You'll be able to test it. Everything will work fine even if you have one whisker. You'll be able to test to see that one whisker was pressed, and the robot will still be able to show you that the whisker was pressed, and it'll still bump into something and turn and go a different direction.
Okay. All right.
So continue with one whisker for now, and then as Ken said, we'll see about getting you some replacement parts.
Okay, and so the question was about homework. So tonight's challenge for homework is build and program one of the following circuits, and I'll send it to you by email too. Touch navigation for the Cyberbot, or visible light navigation, or both.
Oh, there you go. That's a way to not worry about the whisker post.
Yeah, so in your case, Shada, you can move on to visible light navigation. So tomorrow morning, when we start out, we will check our whisker circuits and go over them, or the visible light. So I would suggest at least get the touch navigation working, which is the whiskers. If you succeed there, go straight to visible light, and then we'll talk together about the infrared circuit, which is our first wireless circuit. And we'll build that in class tomorrow among a whole bunch of other things. We're going to look at some examples of advanced projects that are on my desk here and run them around. And we have to look at the teacher resources tomorrow. We haven't really done that. What's available for you to actually use this in a class. I really want to show you all those pieces. So that's tomorrow. And where to go to get help, how to use our educator hotline, and what else is in this world that you've just jumped into. Those are all things for tomorrow. So you've done quite well, actually, considering the limited time. We usually spend about half of a day in person to get to where you are, 4 hours when you run a physical class. So maybe this new way is just way faster for all of us. Who knows?
I'm still having a problem with my motor. I'm only getting one motor to respond.
And you tried switching the motors on the post, right? On the top of the board?
You mean like switching which port they're plugged into?
Yeah, switching the ports and then seeing that the other motor does turn on that port. So we want to isolate the problem to being either the motor or the port or your code.
Okay, let me do that real quick.
Yeah, we'll walk you through this. So for those who are taking off, thank you for joining today. We're going to hang around and just keep answering questions.
Thank you, Ken.
Thank you. You're welcome.
Thank you.
Yeah, welcome. So we'll hang around and see if we can work through this motor non-response problem.
Okay, so it's still the same motor works, the same motor doesn't work with the port switched.
Okay, so you took the non-working motor and plugged it into the working port first?
Yes, and it still doesn't respond.
Okay, I'm wondering, so the
But
port
it
is good
responded
on the...
yesterday when we did the servos, when we were like centering the servos, it responded then.
So this is really interesting because I have not heard of a motor failure, but it's possible. So the port is good, but you verified one motor is not.
Yeah, like I've tried yeah.
Yeah, so the only thing I can think of is try wiggling the wires, the ribbon cable where it goes into the plug. Unplug the servo and just try wiggling those wires a little bit and then plug it back in. What I'm hoping is that basically there's a little
open.
Yeah, I'm just hoping that you can seat the basically if you press the ribbon cable into the plug, you might end up it's possible that the little sleeves that slip over the pins that are sticking out of the Cyberbot board have gone upward. And so if you press the ribbon cable, oh, there you are. Okay, so Ken, yeah, so that ribbon cable, you want to press it in and you want to verify looking at the plug that you can see those little metal connections through the little windows in the plug.
Yeah, you could see these gold colored, what did you call it? Like a housing, where the cable inside connects to these metal housings. Maybe tell us if you see all three of those.
Okay, and just black is supposed to be towards the P19.
No, the reverse.
Okay. I think I had those right before. Hold on, let me.
Yeah, sometimes you're searching for one problem and then there's really a different one.
And where are you? I'm not sure who I'm speaking with. And if you have your video up, we can see what your board looks like.
Hold on one second.
I think it's Annie, or Anne, sorry.
Yeah.
Anne, where are you?
If we can get it, maybe we'll get some video like you said and we can fix this.
Oh, now they're both happy.
Okay, so probably it was reversed when it was plugged in, or very common is this sort of issue where they look like they're plugged in right, but they're shifted over. I'll give you an example. So in this case, I've just shifted it over one, but they look like they're plugged in parallel, but they're really not.
Okay.
Success?
Yep, success.
Awesome. Welcome to Robot Land.
Thanks.
If you need to recenter your servos and they're already mounted in your robot, Ken, could you show the very long, skinny screwdriver?
Or the jeweler's screwdriver?
Yeah.
Or eyeglasses screwdriver. One to fix eyeglasses works.
Yep. So let me get out of my drawer. Yeah, this is actually a flathead, but I think people will get the idea. So you can still recenter your servos for those who are having issues if you just have a Phillips screwdriver that is long. This is an example of one. Okay. You can get into that potentiometer very lightly and still turn it right next to the battery pack. You can't do it with a parallax screwdriver because the plastic handle is in the way, forcing the angle off too much. You might be able to do it.
There is one other possibility that might be why one servo isn't working. When centering the servo, it should slow down before it stops. I think Andy mentioned yesterday that if you turn it all the way to the right or the left, it will also stop.
I have seen it stop with some servos. Some servos keep going, others just stop, and they look like they're centered, but then they don't work right when you try to control them. However,
if you
Anne
can't
got
get
her.
it to turn it at all, but Amy is having difficulty.
Okay.
Here's an interesting one. Are you reading Amy's comment? One of my servos, I tried it on another board and no power. I inserted another motor on my servo board and it worked fine. I'm not sure if this servo was really at fault there.
It worked yesterday when I centered it, but then when I tried to program it, it didn't. So I switched it out with another servo, and the other servo works fine, but that servo doesn't power.
So do you have more than 2 servos?
Yes, my husband has a kit also. He's working on the other program, the Bobot.
Oh.
Same motors.
On his board.
Hi.
Hello.
Hello.
Okay, coworker nomination. We're just trying.
Yeah, so we checked it on the Arduino and we checked it on this one. I've also checked the pin to make sure all the connectors are looking good, and they are looking good. I think this is just a dead servo.
Huh.
Wow, okay. We will send you a new one. Amy, can you chat your
yeah.
Actually, we'll get it. We have it.
Yeah.
Do you mind, Stephanie, on that one?
Making a list.
Okay.
That would be weird. I don't know why it wouldn't work.
So is it 1 servo you need or 2?
Just 1.
Okay.
So it was.
Amy, did you catch the part I was talking about earlier where the little sleeves can end up getting pressed up inside that plug?
Yeah.
Yes.
Okay, so that would be something to just check.
And that could be because it worked fine. It worked yesterday.
I just did the troubleshoot on that and it didn't work.
Okay.
You guys are a really good example of what will happen in class. When you throw 2 students at it, you can pretty much get to the bottom of it.
So nothing. But thank you.
Yeah, we gotcha. We'll send you another one.
Mute.
Now, there is also a way to take apart that plug. I'll see if I can find maybe a little video tutorial on how to gently lift up the little stoppers that prevent the metal sleeves from moving around in the plug. It might be that if you lift out the metal sleeves and then put them back in, first of all, when you lift it out, you can check the crimp connections because those metal sleeves are crimped to the wires that are going into the plug. And so if you're able to take off that plastic plug, you can check the crimp connections just in case there's not a good connection on one of them, and then redo it. The rest would be inside the servo, and if we send you a replacement, I would encourage taking apart the servo. It's kind of fun to see what's in there.
Thank you.
Uh-huh.
Yeah, it'll be good.
Hey, Joan, how's it going with those electronics? I could read her lips, so.
And is there any other type of devices you would recommend buying for some of the advanced cyber security tutorials?
Oh.
Yeah.
An extra microbit.
Microbit. Yeah, extra microbits, and we try to keep it pretty simple in that way.
Yeah. So the things that are supported are an extra microbit, QTI line following kit would be another one. And Stephanie, I'm hoping maybe you can post in links for these, or if we have a page that shows.
I'm showing it right now.
Great.
I'll get to the.
And I should say I have also connected NeoPixels.
The ping was mentioned earlier.
Yeah, the ping. So kind of a picture of all those pieces would be.
Oh, and the projects here.
Here, I'll lay them out just to give you an idea of some of the extra stuff and switch my camera over. I just love doing the sales job.
So the one with your infrared TV remote, is that a remote you buy from you, or is that?
That's our remote.
If you have a universal remote, you can just tell it to be a Sony TV controller, and it might work without worrying about getting one from us. But we do sell it to make life easy.
Okay, so that's the regular Cyberbot kit, because I have those, and just buying that extra infrared TV remote would allow you to do some things that way.
There's also a classroom pack that might be of interest if you're outfitting a classroom. It comes with 12 robots, 2 sets of 10 energy batteries, so you can always have one on the charger and one in all the robots, as the remote, the QTI line follower, and the turret for the ping and the ping sensor.
And that's tomorrow. We'll go over that too.
Yeah, it's everything except for extra microbits, but we also sell microbit Go things.
And it's difficult to emphasize how cool it is to have a second microbit, because you can do all kinds of radio control fun stuff between your extra microbit and the one on the robot.
So super brief summary, and we'll save this for tomorrow, would be an extra microbit. So you have a tilt controller and also ability to send and receive radio. Ping mounted on a bracket on a servo, so you could turn and take ultrasonic measurements. The gripper, not yet released. And then the infrared remote control, okay, which is this. And then the line follower are the most popular ones. All demo tomorrow.
We have, I know Joan is waiting for assistance, and I don't know if James Welsh is also.
So webinars do get posted, and let's take care of Joan's question, then head towards ending the meeting.
James, are you waiting for assistance as well?
I'm so sorry. Okay, so because I have no breadboard experience, and I'm just checking that I've got these, and you can't see, can you?
No, we see.
We can almost, yeah.
Is that better? There we go. All right, so I think I've got this in the correct place. I think they're the correct resistors. Are they supposed to be like this high up?
Yeah.
Yeah.
Oh,
now,
okay.
one thing to check is, are those resistors going into the black sockets that are next to the breadboard? So there should be, I don't know, is it like P8 and P7, those connections? Are they going into the white breadboard sockets, or are they going into the black socket that is next to, say, I forget which ones, P8, P7, something like that for the, let me get to the.
They might be going into the breadboard right now, but I'm just really quickly changing that.
Okay. I call that a bomb site error, because the bomb doesn't drop into the right. Yeah, very good. And then the next thing to do is to run the test program and try pressing the whisker against the post and see if it gives you 1s and 0s in response to pressing the whisker against the post and releasing it.
Okay, so this is where I'm like having another little bit of problem here, because I know you said that the whiskers shouldn't touch each other, right?
No, they can.
Yeah, that's fine.
Definitely.
That's okay. Yeah. Okay, well that might help. These are like, my whiskers are having a life of their own. Oh, it's this one. They're just kind of like wanting to go everywhere.
They're pretty springy metal, so we get that.
Then one other question is, taking a close look at the resistor color codes.
Yes.
You have 2 resistors that are going to I/O pin sockets. What numbers are those again? Is it like P7 and 8 or P? What numbered sockets are those?
Thank you for asking that interesting question. I think I'm just, challenged visually right now. From what I can tell right now, it's P7 and P9.
Okay, that sounds good, as long as that's what it shows in the tutorial, which I don't have up.
Yeah,
But
I've got that right beside me, and it shows them going. Of course, I have them in the. Let's forget that I had them in the grid box thing. Okay.
That's a 1 in 8 mistake, so not
okay,
to worry.
so here's a question though, because I looked at it when I was trying to construct it, and so the P9 and the P7 are plugging in to like these. What do you call them now? What are these things? these things here.
Oh, 3-pin headers.
The 3-pin header. Okay, so they're plugging into the like holes beside that, right? So I've got the resistors going to the 3V, and I'm trying to make sure that those wires are not touching each other in any place.
Yeah, because the resistor leads, you definitely don't want them touching each other. The whiskers can touch each other, but resistor leads should not.
No, I'm trying to keep everything separate. My dad was an electrical engineer, but I know nothing. So
just enough to be afraid, like when I started.
I'll tell you the one thing I know: never mix water and electricity. And you don't really want to know the reason why I know that. But
no, we don't.
Anyway, so yeah. These 3-pin headers, what's happening? One thing that's happening is I'm fooling around with them here. Like I'm trying to press the whiskers, and when they touch the 3-pin, maybe I'm just being too forceful. The 3-pin things are tilting like this.
They will if you push really hard. When it's driving around, it doesn't have to push very hard, and it's okay if it tilts up a little bit. As long as it's still making connection in its sockets, things should work.
All right.
The other thing is if they tilt up and then the whisker bumps into the plastic, so there's a plastic part of the 3-pin headers, then it won't be making an electrical connection.
It won't make the contact, right?
Yeah, so sometimes
that bottom one there.
Yeah, and you can even bend the whiskers upward a little bit so that they're riding a little. Oh, thank you, Ken. Take a look at Ken's screen. Isn't that beautiful?
Oh, right. Okay, but yours looks so much closer. Like, did you not?
That's just because I travel with these on airplanes. I don't want the parts high off the breadboard, so I cut them.
You trim them, huh?
I trim them. You don't need to do that.
Because I'm kind of, you have no idea how much I wanted to pull out the nose pliers and do that, because it would make it simpler, I think.
Yeah, get yourself a...
Cut them too short.
Now the other thing to
never
do
give the needle nose pliers to the students.
So the other thing to do is check very carefully with your magnifying glass, because the resistors that are going to P7 and P9, you want those to be the red, brown ones.
And that's what I've got. Well, it kind of almost looks like a red, orange, brown. But I don't know if it's the light or my eyes. I'm really not sure. But red, brown is kind of what it's supposed to be, and it looks like red, brown. And then the other is the brown. Oh, good. So it must be red. All right. So then there's the brown, black,
orange
ones, and they're the ones going to the 3.3 volts,
up
right?
here, right?
Good.
Okay.
So I think we're ready to run the test
I
code.
think we're good.
Yeah.
I just have to download the code and do all of that stuff, and I'll come back to you tomorrow. Thank you so very much for your time.
You're doing great.
Have a great day.
Likewise.
And check out my submission.
I hope we got a winner.
Ken, you're going to love it, Ken. You're going to love it.
Okay.
And then James has been waiting. Can we still help you, James?
Yeah.
You're muted.
Yes, thank you. Could you show me your whiskers, how they cross over? I did it the way I thought it's supposed to, but it doesn't look correct.
Okay, can you rotate your robot, Ken, so we can just see how the whiskers are offset?
Yeah, I'm going to provide you a picture here. Okay, let me send that off to myself. And then in the meanwhile, I don't have a doc cam, but let me just bring this picture up. Give me just a... It's kind of a clunky process. I'm just taking a picture with an iPhone, sending it to myself. Okay. Does that work for you, James?
Now hold it sideways so we can see how they're offset from each other.
Oh, and like this?
Like a front view? There we go.
Yeah.
So they're crossing, they're hitting, and that's okay. But so the idea is that they hit with just a light press that metal post with what we call the 3-pin headers. So a light press, if you look at it this way, a light press causes it to hit the 3-pin header.
Is it supposed to be that loose as you have it, or?
Well, they're bending, so they're tight in the screws. The screws are tight, holding them securely. But the flexibility of the metal is allowing them to hit.
Okay. All right, very good. Thank you very much. Appreciate it.
Yeah, it's a tricky little circuit. Here's a picture of the close-up. Mine are pretty beat up. You can see my 3-pin headers are bent over and stuff. But you notice the 10K resistor is right in the same row coming off. And then the other one's going to the I/O pin. Good? Okay, cool. Anyone else?
Jack, are you okay?
Yeah, no, I was just going to say, I sent Andy a couple of emails. I still can't flash. No connection to the connection to the robot. I've been able to download and just drag and drop, no problem.
Ken,
But
can you share my screen out? Thank you, Brother Jack. Brother Jack, I'm really sorry. We talked and then I didn't get back to you with a link.
I might ask you guys to take it offline because I have to get ready for the next event.
Okay, let's do that.
Is that acceptable? Okay, so probably using Hangouts is the best way the two of you could handle that.
Okay.
So do you use Hangouts, Jack?
Yep.
Okay, invite Andy. He's alindsay@parallax.com.
Okay. I will get that set up right now.
Yeah, we'll figure it out. We can do everything but replace your computer.
There we go. All right. Take care.
Anybody else? Okay. We're closing down, closing out. Wonderful. Okay. Ending the webinar meeting now. Thank you.
Bye, Ken.
Okay. See you in a little bit.